In this lesson, I'm going to briefly give an overview of the topics in this course, and we'll dive into some of our technology tools. In this course, we'll discuss various statistical devices to perform data analysis for the biological sciences. We'll start with a couple of lessons to get familiar with the technology, and then jump into data visualization. From there, we'll discuss random variables and sampling distributions before diving into what is generally considered one of the main goals of statistics, estimating population parameters. We'll discuss two-sample inference and a couple of other useful topics, analysis of variance and regression. By the end of the course, I hope that you will have working knowledge in these techniques and will be able to apply them in your fields of study. We will use two primary tools to analyze data, R and Excel, or if you prefer, Google Sheets or some other spreadsheet program, but I'll be demonstrating Excel in this course. Excel is a well-known spreadsheet program that can execute calculations, produce quick visualizations, and perform basic statistical analysis. It's not, however, always the best at more advanced statistical techniques. R is an open-source programming language frequently used in analysis of big data. Both Excel and R are able tools, but there are pros and cons to each. Excel has an easy point-and-click interface, and it is easy to organize data in a spreadsheet program. The learning curve in Excel is minimal, and it can produce quick visualizations. Sometimes, though, it can be difficult to customize analyses beyond the built-in functionality of Excel, and often the point-and-click actions have to be repeated for different data sets. R can easily reproduce analyses with different data, and it is highly customizable. R also has many built-in tools for statistical analysis and visualization. Lastly, R is open source and free. One slight disadvantage of R is that it is a programming language with a less user-friendly interface, and the learning curve is a little bit steeper. Let's jump into an example. We want to use Excel to organize qualitative data into a frequency distribution, and we'll create a bar plot. We will also ready the data for import into R. Okay, so in this example, we're going to start off with a file here that contains insect data. These are insects that have been trapped, and what we want to do is we want to construct a frequency distribution, and we want to construct a bar plot or a bar chart. We're going to start off here with just getting to know Excel a little bit. I see that I've got my data over here, and if I just go in here, I see I've got a hornet, honeybee, wasp, others. Those are my four categories that I've got. And I've actually got quite a number of them here. It goes all the way down to, 3,070 or so. And so what I'm going to do is I'm going to start with what I consider to be pretty good practice here. Something that makes it easier to put data ranges into different types of formulas. I'm going to name this entire data range over here. I'm going to select everything, not the label up here, but I'm going to select all the data itself. Now let me work through a couple of things. Let's see here. I'm going to press Control and the down arrow key, and what that does, it takes me all the way down to the very bottom of that list. Okay, if I press Control up, it takes me up to the top of that list. Okay, now let me do something else. I'm going to press the Shift key and the down arrow key, and you can see what that does is that selects different things here in this list. So I'm going to combine those two actions. I'm going to press Shift to select things, and I'm going to press Control and then the down arrow key, which will select that entire data list. All right, now what I want to do is I want to call that entire range a name. You can do this in different ways. You can go to the Formulas tab and define name here, or you can go into the Name Manager and define names there. I find that the easiest way of doing this is just to click into this little box right up here and just type in a name. All right, so I'm going to type in this, I'm going to call this insects. And press Enter, and now insects is a name that refers to that range of data. Okay, so now let's move forward with doing our frequency distribution. All right, I know I've got some different categories here. So I'm going to go in here and say, okay, category. And I know I need to count these things up. So I'm going to call this, this will be frequency. I'm just going to say FREQ, okay. And my categories are, well, I've got a honeybee. That's one of my categories. I've got hornet. That's another category. Wasp is another one. Other, and that's my 4 categories. I don't have anything that isn't one of those 4. Now, to construct a frequency distribution, what I need to do is I need to count up how many of each one of these different categories occurs in my list. I'm going to use the COUNTIF command. Now, to type in a formula in Excel, I start with the equal sign, and my command here is COUNTIF. Now, COUNTIF is going to ask me for 2 different things. It's going to ask me for the range of data that I'm looking at, and then it's going to ask me for, well, what's the criteria for counting? Now, my range is what I just called that. I just named this whole thing INSEX, and so when I type in INSEX, it refers to that data range that I defined here just a little while ago. Okay, so that's where I want it to look. Now, what is the criteria? Well, my criteria is that I want it to equal this value right here, this honeybee. I'm just going to select this cell right here, C4, which is honeybee, and that's basically saying I want you to count if it finds in this entire list of data over here something that equals what's in C4. And let me close out the parentheses and press enter. And I can see that there are 664 instances of honeybee in my list. Okay, great. Well, now I could go through and I could do the same thing here for hornet. I could type in the COUNTIF command, put INSEX in there as the range, and then type in hornet or say, hey, I want you to look at C5 for that. But I've already basically got the command written in up here. So if I just copy this formula down to the next one, let's see what happens in that case. I'm going to copy, and I'm going to paste that formula down to here. And we see that what it does is up here when we were looking at C4 for this one, when it copied down here, it went down to C5. So that's something to take a note of. When I'm copying formulas, it's going to change those reference cells when I copy it from one cell to another. Now, if I do the same thing here for these last 2, I'm just going to press Control-C to copy, Control-V to paste, and I can see that I've got myself a frequency distribution. And one thing you'll find about me is that I like to clean things up so they look nice. So here we go. We've got ourselves a frequency distribution here. Well, once I've got a frequency distribution, it's pretty easy to do a bar plot. I'm going to just select all of these things right here, and I'm going to press Insert, and I can select lots of different types of plots over here. The one I'm looking for is actually this one. Now, Excel calls this a bar chart or a column chart. A lot of times you can go into recommended charts, and it'll give you some suggestions for what you could use. It looks like what I've got right here is exactly what I'm wanting to see. I want to see this kind of a bar chart here. You can go in here. One of the nice things about Excel is that it easily and quickly does different types of graphs, and you can change these things. You can change the look of it just by clicking some of these different options up here. You can even change colors if you want to, and do all these types of things. I can also click this little plus over here, which gives me the different chart elements. For example, if I didn't want to see the data elements, I could just take that off. If I wanted to see a chart title, I could tell it to add that. I could tell it to add axis titles and so forth. So I can go in here and I can make this thing look any way I want to. And it's also easy to copy this. Just take it and copy it, and I can go into Word or PowerPoint or some other application and paste it in there. And it's nice and easy to do that. Okay, so we've seen how to use Excel to make a frequency distribution for qualitative data. We've seen how to do a bar chart, and we can see that this is a fairly straightforward process. And one thing I want to do here is I want to think about a process for taking data from Excel and moving it into R. For example, suppose that I wanted to have these values right here, this frequency distribution, and put it into R. Now, what I will do is I'm going to go in here and just open up a new file. I want it to be a blank worksheet. I'm going to select these values and just copy them. And let me go into my other worksheet. So I'm going to paste these in here. Now, what I need to do is I need to paste these in as just values. So don't just hit paste, hit this little arrow here and say, okay, let's paste these in as values. Now, if I'm going to pull something into R, basically I need it to be a CSV file. That's a comma separated values file. So I'm going to go in here and just save this as a comma separated values file. Now let's see, I need to tell it where it needs to go. Okay. And I need to give it a name, so I'm going to call this insect frequency distribution, something like that. And I need to select this as a comma separated values file, CSV. So I'm saving this. And what this does is this prepares it into a format that can easily be pulled into R. Now let's just take a look at that. Now we're going to talk about R a whole lot more here in the next few lessons. But at the moment, let's just go in here and just see how to pull that in. If I go into the environment, I can import a data set. I need to import it from the reader package right here. And we'll learn about those things here in the next few lessons. Okay, I am going to find that data set. Okay, just browse where I just put it. Okay, so I've got my CSV file right here. And I'm going to import that. And basically that data set now exists here in R. And so I can go in and I can do some different things with this. So in this example, what we've seen is how to take a list of data, how to give it a name, how to use the COUNTIF command to find a frequency distribution for qualitative data, how to do a real quick simple bar chart, and how to save data in a CSV file to ready it for import into R. Consider another example. Here, we want to use Excel to organize quantitative data into a frequency distribution, and we'll construct a histogram. Recall that quantitative data tells us how much or how many of something there is, and a histogram is analogous to a bar plot when we have quantitative data. Okay, so in this example, what I'm looking for is Bigfoot sightings. I've got the state of various Bigfoot observations, supposedly. I've got the date of those occurrences. I've got the temperature of the occurrence and also the moon phase. Let's go in here and see if maybe we can work with the temperatures. I want to create a frequency distribution, and I'll go on and I'll construct a histogram when I have that in place. So if I'm going to do a frequency distribution, remember when I had categorical data in the last example, it was pretty easy just to use the COUNTIF command. Well, now we got to think more along the lines of classes. We're going to come up with classes, and we're going to tally how many of these temperatures show up in each one of those classes. So in order to do that, I'm going to go over here. I'm going to start off by naming this range of all these temperatures. And I'll do this sort of the same way I did before. I'm going to press Control, Shift, and down, and that selects all of those data values. I'm going to give those things a name. I'm going to call those temps. So now whenever I refer to temps, that's just this range of data right here. So in order to come up with a frequency distribution, and in particular those classes, I need to know, well, what's my starting value? How small should I start with my classes? And in order to do that, I'm just going to take a look to see, well, what is the minimum temperature? And I can easily find that using the min command. So equals min, and remember, I'm just looking at temps. I've already named that range. And it looks like the minimum temperature is negative 0.62. We'll do the same thing here with the maximum. So max temps, and I can see that the maximum temperature is 106.51. So when I set up my classes, I need to have something that's a little bit less than negative 0.62 in my first class, and I need to make sure that in the last class it goes up to at least 106.51. I'm going to set this up in such a way that I can play around with the different classes. I'm going to go in here and say, okay, well, what's a good starting value? I know it's got to be something less than negative 0.62. How about if we just put something like negative 2 there? And I also want to think about an increment, okay, from one class to the next. Well, how big of a gap is that? And I'm just going to call that increment, INC. And I don't know what to choose here. I'm just going to try something, and if it doesn't work, I'll come back and play around with it. I'm going to choose something like maybe 5. Okay, so now I'm ready to set up some classes. I want to know what is my lower value of each class, my upper value of each class. I'm going to put a couple of other things in here. One thing I'm going to do is the midpoint. And I'm just thinking ahead here to thinking about when I do my histogram, I want something to go on that x-axis. So I'm just going to choose the midpoint of each class to go there. I'll need to count up these things, so I'll call that the frequency. And I think I'm ready to begin. Now my lower value in the first class, that's just going to be the starting value right here that I chose. It's just some convenient value that is less than the minimum. Okay, so I'm just equal G4 gives me that value. Okay, now let's think about the next lower one. Well, that would be this lower one plus my increment. So that would be F8 plus this value right here in G5, that increment value. All right, so my next value is 3. And I can see that my first lower value is -2. My next class starts with 3. That's an increment of 5. Everything looks great. So how about if we just copy this from here down to the next cell? Okay, something didn't work out right. That's not the right value. And what happened is that when I copied that, remember when you copy formulas, it copies those cell references. Let's take a look to see what is this referring to. Well, it's looking at this lower class and it's adding on what's in G6. Well, there's nothing in G6. And I didn't want it to do that. I wanted it to stay at G5. So I'm going to have to make a change to my formula here. All right, let me erase this one and go back to the cell above it. I'm going to tell Excel, I don't want you to change that cell reference when I copy these formulas. And Excel does this with what's called an absolute reference. If I put a $sign in front of the G and a $sign in front of the 5, then that's going to fix that reference. It will not change when I copy that formula from one cell to the next. And we can see here that now if I copy this down, and if I just go in here and take a look at these, they are always looking at G5, which is exactly what I want it to do. Okay, so I've got some values here. I'm going to go ahead and copy this on down a bit because I know I need to get up to at least 106.51. What about the upper value? I want the upper value to be the lower one plus something that's just a little bit less than this increment right here. So how about if we put in equals this lower value plus the increment minus 0.001. And that gives me some upper value here that's just a little bit less than the one down here. Now let's remember, I'm going to have to go in here and tell it, when I copy these things down, I don't want it to copy down that G5. I want G5 to always refer back to this value up here. And so I'm going to go back up to this formula and put in a $sign in front of the G and in front of the 5. And by the way, let me take these out. A quick way of doing that is that if you go back into the formula and just put the cursor over G5, if you press F4, then it will do that automatically for you. I think I'm ready to copy this all the way down. Okay. I can also see that I've gone a little bit further than I need to down here. I've got 107.999. There are no temperatures that are greater than that. So I'm just going to delete these last few down here. And I've got my classes. Now remember, what I want to do is I want to count up how many temperatures are between these two values and these two values and these two values and so forth. Well, let's go ahead and do our midpoint. Our midpoint would just be the value that's right in the middle of these two right here, the lower and the upper. And that's pretty easy. That's just going to be the lower value plus the upper value divided by 2. And I'll just copy that down. Here's another little shortcut. When you have a formula that you want to copy down and there's a column of formulas next to it, you can just double click on this little box that's here in the lower right hand corner and it automatically will fill those in. Okay, so it looks like I've got my lower, my upper, my midpoint. All right. Last thing to do here is I just need to go in and I need to find my frequencies. Well, Excel has a formula for that. It's the frequency command. And so I need to start off by putting in my data array, which is just my temps range. And then I need my bins array. Now it turns out that my bins array is going to be my upper values over here. And essentially what that does is it says, okay, count everything that's below 2.999 and then everything that's above 2.999 and less than 7.999 and so forth. And so it's just going to go in here and count all these different things right here. And I've got myself my frequencies here. Let's go in and do a histogram at this point. And I'm going to use my midpoint. That's what's going to show up on my x-axis. And my frequencies is what's going to show up in the histogram. So I'm just going to go in here and insert. Let's see if I hit recommended charts. Looks like I get something right here. And there's my histogram. Now, one of the main reasons for looking at these types of things is that it gives us an idea about what the distribution of these data are. And it turns out that in this case, what we have is a distribution that is skewed to the left. Skewed to the left means that we have a long left-hand tail. Other common shapes would be skewed to the right, which would have a long right-hand tail, or symmetric, which is approximately a mirror image on both sides. Let's finish this lesson with some common terminology. Statistics is the study of procedures for collecting, describing, and drawing conclusions from data. A population is the entire collection of individuals about which information is sought. A sample is a subset of a population. It contains only those values actually observed. Qualitative data classifies individuals into categories. Quantitative data tells how much or how many of something there is. A distribution of data is symmetric if its right half is a mirror image of its left. A distribution is skewed to the right or positively skewed if it has a long right-hand tail. And a distribution is skewed to the left or negatively skewed if it has a long left-hand tail.